In the previous video, tilt station survey, control survey was adjusted within itself in a local grid coordinate system. Check there were no issues with the data. Same data is going to be used in this video, but constraining to a known coordinate and azimuth. So I'm going to start by importing data that was created from the processing of the local GNSS network. So OS National Grid coordinates, and the coordinate system for this project is also OS National Grid. So I'm going to bring these in with control quality status on them. Next, I'm going to import the total station data. Same survey file that was used in the previous video for the checking process. So I'm going to bring this in. Now there is a merge prompt appear because the local grid coordinate in the survey data is quite different from the national grid coordinate that's been imported from the CSV file. So it's just checking that those are referencing the same position, which they are, although they have very different coordinates at this point in time. So I'm going to tick to merge and hit import. So it's saying some points cannot be computed. Well, this is the local grid values that won't be computed. So you can see this big discrepancy between coordinate in the survey data and the coordinates that were processed from the GNSS. So that's to be expected given what we're working with here. So first thing I'm going to look to do is remove that local grid coordinate, as that is no longer required anymore, and anything else that may not be needed for the processing as it needs to happen in this project. So in Project Explorer, if I look in imported files, I can see my nice list of the station setups. The first setup was at coordinate or point L2. There was a backsite from L2 to L1. So we've got a coordinate here. This is a local grid coordinate, and we've also got the azimuth that was entered when the survey was taken of 0 in this case from L2 to L1. So we don't need that, and we're not going to need this local grid coordinate either. So what I think I'll do is I'll go up to the points list, find L2. Here's the local grid coordinate. So it could be disabled if there was some reason to keep it, but there isn't in this instance. So I'm just going to right click and delete that from the project. And the same for the azimuth, as I've got a coordinate for the backside point, which is L1. I don't need that azimuth either. So again, it could be disabled, should it be needed later on, or again, can delete it. And having made those changes, I'm going to press the red recompute button, and the data is now reduced and updated. I've got a warning flag here on L2, so you always need to check what the warning flags are prior to any further processing. So it's saying that L2 is out of tolerance, so there's some data that references L2 that's different, or would position a coordinate differently by 23 mil to the coordinate that's initially being assigned to L2. Now that's not too surprising in this instance because the survey was extending in this direction and then come back in this direction, so there's going to be some misclosure between the initial coordinate for L2 and the data going around and coming back to L2. Okay, so let's go into the adjustment. Just a refresh on the settings, just to remind ourselves what's set here. So for the default standard errors for the total station data are coming from the imported job file, but the centering errors are set here in the project, and these are currently as shown here. 1 mil in position and a couple of mil in height. And it's set to use all the results of the mean angles rather than the individual observations, but you can use either. You just make your choice here. Okay, so let's begin the adjustment. We'll just constrain point L2, so it's a minimally constrained situation. Again, everything is going to adjust around the position of L2. We'll keep that as a fixed reference. And that coordinate of L2, as mentioned earlier, has come from the GNSS local network post-processing. So hit adjust. So it's warning me that I do have some project errors still. Know what these are. They're down here. There's this discrepancy between the initial position of L2 and some additional observations that can position L2. Given that we've also got a GNSS derived coordinate here, again, not too unexpected. So say yes to continue. The reference factor is 0.45, chi-square test has failed, and that will be because the error is less than was anticipated based on the data and the input parameters. So if I want to steer my chi-square test towards a pass, I'm going to need to get that reference factor closer to 1, which means adjusting the weighting. This could be done individually to see what effect that has on the network, or they're likely to all to be needed to be reweighted, so it could be done in one go. But I'll do them one at a time. You can see the reference factor creeping closer to 1. Okay, so reference factor of 0.96, chi-square test has passed at this point. Let's take a look at the network adjustment report and see what we have in terms of control coordinate comparison, so comparing the adjusted positions to the input GNSS coordinates. We can see we've got up to about 10 mil difference in northing there, and a few mil in easting, maybe 5 mil there. The elevation I'm not so concerned with this data set, as I'm going to be using digital level data later to compute the elevations for the points. But equally, if you were interested in the elevations, then the elevation errors are shown in the table here for all of the points in the project. So at present, the elevation errors, the easting and northing errors, all looking very reasonable, small values. Scroll down, look at the standardized residuals. Nothing is being flagged as an outlier, so an unusually high standardized residual compared to the rest of the data set. So if I scroll down to the bell curve histogram plot, there's no data sitting outside this computed tau value. So we've got no outliers, which is great. I'm just going to minimize that report and proceed by making an additional constraint. So we have a known value for L1. So we could make a azimuth constraint, which constrains the azimuth based on the GNSS observations from point L2 to point L1. The network adjustment algorithm here will also let you fix data that doesn't have a direct observation between them. So if I wanted to orient the network by fixing the azimuth between L2 and L7, for instance, I could do that as well, even though there is no direct total station observation between L2 and L7. I'll show both scenarios, so we'll begin by constraining the azimuth from L2 to L1. So that's done here on the Constraints tab. We're going to add an azimuth constraint, and that is going to be from point L2 to point L1. The azimuth from those two control values is computed and shown here, and the box is ticked as fixed. So now when I adjust, there'll just be a slight bit, you can't even see it on the plan view, just a slight bit of rotation to align the network to that constrained azimuth. So no change here in the reference factor, chi-squared test has passed, so the network is still good with that additional constraint in place. You can select all of the points here and see their error estimates, and of course these values are also in the network adjustment report. So in terms of constraints, fixed L2 in 2D easting, northing and elevation, even though I'm not interested in the elevations from this particular network, processing of the total station data, and there's a constrained azimuth from L2 to L1. So just hit OK on that for now. So remember, we have the point derivation report if we wish to see how values of control coordinates have changed within the network. So for example, point L6 here, I could look at the point derivation report for point L6. So at the top we've got the adjusted coordinate for L6. This is not the GNSS derived coordinate now, this is the adjusted one, and I can see that because it's listed in the top of this table. There's no delta between in easting and northing in elevation from this headline figure at the top. So that's the adjusted coordinate, and we can see the adjusted symbol shown next to it. Below that in the table is the imported GNSS derived grid coordinate, and we can see that there's a 1 mil difference here, 9 mil in northing and 6 mil in elevation. So again, not too unexpected when combining total station data with GNSS derived data and referencing to that data that there's going to be some difference between the two following the processing. So it's a good reminder that the values that are assigned to the points ultimately are the highest quality values, and having done an adjustment, the adjusted values take priority over those imported points with control status. Let's look at the alternative scenario now. So here I will go back to Adjust Network, go back to Constraints, and this time I'm going to constrain between L2 and L7. Let's just delete that, I'll put it in again. So we're going to go L2 to L7. So we have our computed azimuth here from the GNSS derived control values, and now I can adjust. So L1 this time is going to float, if you like, as we've constrained the azimuth going from here down to here. So chi-squared test is still passed. We've just oriented the network, pivoted it around L2 using an alternative azimuth to the direct observation that was based on the azimuth between L2 and L1. So there is our final report for the adjustment, showing how much difference there is between the GNSS derived coordinates and the adjusted coordinates from the total station survey, easting and northing error estimates for all the points, in addition to the elevation and estimated elevation error. Error ellipses are looking small, and there's no outliers, nothing is flagged in red here. So that concludes the processing by holding one coordinate fixed and using an azimuth to orient the rest of the network.